Okay student, in the last class we discussed about some exercise problem, right? Yes, we discussed in some exercise problem. Yeah, for last session, right student? So based on that only the exercise problem 1.1, right? 1.1, the second problem, they're asked to find. So you should see the questions in your textbook once again. Show that any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5, where q is some integer. We have to prove this thing. How to prove? Let's see. We know that in the last class only we learnt what is lemma and what you mean by algorithm. Here they are telling let a be any positive odd integer, then b will be 6. Applying Euclid's division algorithm. By applying Euclid's division algorithm, we get a is equal to 6q plus r. We know that r is less than 6 and it is greater than 0. What are the possible remainder? The possible remainder are, it is 6 means b is equal to 6 means the remainder will be less than that number 6. Then 0, 1, 2, 3, 4, 5. A is equal to 6q or 6q plus 2 or 6q plus 3 or 6q plus 4, 2, 3, 4, 5. Okay, since a is a odd, we neglect 6q, 6q plus 2, 6q plus 4 as they are divisible by 2. Then possibility will be a is equal to 6q plus 1, 6q plus 3 or 6q plus 5. Why means because they are asking to find out, what they are asking to find out, show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. That's why here we are taking let a be any positive odd integer and b is equal to 6. By applying Euclid's division algorithm, we get a is equal to 6q plus r is less than 6 and greater than 0. The possible reminders are 0, 1, 2, 3, 4, 5 and a is equal to 6q, or it can be expressed as 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4, 6q plus 5. Is it right? We can express. Sorry, here the whatever the remainder is there, you should express in terms of that remainder. 6q, 6q plus 1, 6q plus 2, 6q plus 6q plus 2, 6q plus 3, 6q plus 4, 6q plus 5. This is in the form of lemma. A is equal to bq plus r form. Since a is odd, so a is odd means we have to express it is in the form of odd integer. We have to neglect 6q, 6q plus 2 and 6q plus 4 because they are all divisible by 2. That's why a is equal to 6q plus 1 or 6q plus 3 or 6q plus 5. Q is a odd integer. Okay student, let's again we can explain one more problem based on exercise 1.1, third problem, question number 3. An army contingent of 606 members is to march behind any army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? So if you read that question, okay student, you exercise the next problem. Can you see now here? So here they are asking an army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? So for this solution it's very easy to find out. The maximum number of column is equal to is nothing but HCF of 606 and 32. That means we have to apply either Euclid's lemma or algorithm for 606 and 32. By applying Euclid's lemma or algorithm, so we can find out, divide 616 by 32. 32 ones are 32. Subtract 32 from 61, you will get 29. Bring down 6. Then what happens? 29 will become 296. 32 19s are 288. You will get the remainder 0. So again, by applying Euclid's lemma or algorithm to find the HCF of 616 and 32, what you will get? 616 can be expressed as 32 into 19 plus 8. This is nothing but it is in the form of A is equal to BQ plus R, algorithm lemma, Euclid's division lemma. Again 32. So if you divide, you can see the working step there. Again 32 if you want, 8 4s are plus remainder will be 0. This will be also same in the form of A is equal to BQ plus R. Therefore, the remainder is equal to B. Therefore, HCF is equal to 8. Hence, the maximum number of column of 606 and 32 is 8. Okay, now come to the second topic of real number. Second subtopic of the subtopic of real number, the fundamental theorem of arithmetic. What is the fundamental theorem of arithmetic? The fundamental theorem of arithmetic says that the second topic in the last session we learned real number consists mainly 4 topics. First topic we discussed. Now we are discussing the second topic, the fundamental theorem of arithmetic. Every composite number can be expressed as a product of prime numbers in a unique way apart from the order in which the prime factor occurs. I'll repeat again. What is the fundamental theorem of arithmetic? Every composite number can be expressed as a product of prime numbers in a unique way apart from the order in which the prime factors occur. For example, if P and Q are any positive integers, then HCF of the two numbers into LCM of the two numbers, that is always equal to product of their number. That means HCF and LCM, the product of HCF and LCM is always equal to product of the numbers. Here P is a prime number and A is a positive integer. Then HCF of PQ is equal to LCM of PQ, that is equal to product of P into Q. So keep this point in your mind. The fundamental theorem of arithmetic states that every composite number can be expressed as a product of the primes, and this factorization is unique apart from the order in which the prime factors occur. It also known as unique factorization theorem. This fundamental theorem of arithmetic is also can be called as unique factorization theorem. Thus, any integer greater than 1 can either be a prime number or can be written as a product of prime factors. And very most important point we have to keep in your mind, a number is called a prime number. It has only 2 factors, the number and itself. One is neither prime and nor composite. 2 is the smallest prime number. It is the only even prime number. You have to keep the points. I'll repeat again. A number is called a prime number if it has no factors other than 1 and the number itself. 1 is neither prime nor composite. 2 is the smallest prime number. It is the only even prime number. Two numbers are said to be co-prime if they have no common factors other than 1. Then their HCF is equal to 1. You can understand this fundamental theorem by solving some problems. This is based on the exercise. The next exercise, the topic 2 is based on the exercise 1.2. Now shall we start that problem to solve and try to understand the problem theorem. Now take the first problem. What is the first problem? Find the, so you can see in the exercise textbook, express as a product of prime factors. Prime numbers already learnt, it has only two factors, 1 and the number itself. 140. 140 if you factorize prime numbers means start with prime number only. So 140 can be divisible by 2. 270 is again 70 can be divisible by 2. 235 is so 5 is there, we know that prime factorization method. So again 35 can be divided by 5. 7 is 35, 7 1 is 7. If we express what are the product of this will be, we can write as 140 can be expressed as 2 into 2 into 5 into 7 into 1. So if you write means, if you express this is, it has the same numbers, 2 into 2, 2 square, 5 only 1 digit, 7 also 1 digit, 1. If you write also okay, not write also okay. Then 140 can be expressed as a product prime number. Is prime number 140 is equal to 2 square into 5 into 7. 156. 156 can be, again take the second problem, the same thing, this is already learnt in your previous class. 156 can be factorized, that means prime factorization, that's why we will start with 2 only. 2 7s are 14, 2 8s are 16, again 2 3s are 6, 2 9s are 18, 2 1s are 1, again what will be left here? It will be not possible for 2. That's why go to the next number. Easily it will be divisible by 13. 3 also not possible, 4 also not possible, 5 also not possible. That's why we know that. That's why I did directly 13 ones are 13. Again, if we express this factor, what are the factors of 156? 2 into 2 into 3 into 13 now. So when you express this one, 2 into 2, 2 square, 3 into 13. Therefore, we can write 156 as the product of prime factor number 2 square into 3 into 13. Likewise, we can take one more problems. 3825, that means 3825. This problem also same only. First find the factors of 3825. 3825. So we can't divide because the last digit, units place digits start with 5. So it will start with 5 means we have to divide either 5, 3, 7 like that, odd numbers only. Then we divide 3825, 3 ones are 3. Again what will be left? 1 will be 8 will be left, 3 2s are 6, again 3 7s are 3 1s are 3, again 3 2s are 6, again what will be left here? 20, 3 7s are 21, 1 will be left, 3 5s are 50. Like next I will divide by 3, 12, 1275 divisible by 3, 3 4s are 12, 3 2s are 6, 1 will be left, 3 5s are 15. The units place start with 5. Again we can directly go through the, go with 5 only. 5 8s are, so 5 8s are 40, 2 will be left 25, 5 5s are 25, 5 1s are 5, 5 3s are 5 7s are 35, 17 1s are 17. Like that we can express 3825. What are the factors of this number? The factors of this number will be 3 into 3 into 5 into 5 into 17. That means these are the prime factors of the given number 3825. Then if you express as a prime number, prime factors means here we have the same two factors, 3 into 3, 3 square, 5 into 5, 5 square into 17. Like that, if you take the next last one, another problem, 5050. This will also starting with this number 0. We can start with 5 ones are 5, 0 cannot be divisible 0. Again, you can write 5 zeros are, again 5 ones are. Like start with 7, 143, and again 11, 143 can be divisible by 11, 11, 13s are, again you can continue means 13 ones are 13. So what are the factors of 5050? Here we don't have same factors. That's why what are the factors of 5050 means is nothing but 5 into 7 into 11 into 13. Likewise we can solve the problems of the exercise problems. That means here we have to find out the express the given number as a product of prime factors. Next we can learn what is the relationship between HCF, LCM and the given numbers. What are the relationship between HCF of two given numbers? So here the next concept will be the relationship between numbers and their HCF and LCM. How to find out the relationship between HCF, LCM and the given numbers. For any two positive integers a and b, the relation between these numbers and their HCF and LCM are given by HCF of any two numbers into LCM of any two numbers. There is equal to, that's always equal to product of their number. That means we can understand here the HCF of any two numbers is always equal to product of their number. That means H means HCF, L means LCM. HCF into LCM is equal to product of their numbers. If you want to find out HCF, what is the formula? A into B by H. If you want L means A into B by, if you want H, so here we have to write product of numbers divided by L. If you want L means product of any number divided by H. Okay, now if you want any number means H into L is equal to A by B. H into L by A is equal to B. Like that we can transpose the equations. Mainly we have to understand what is the relationship between the given numbers and their HCF, LCM. If they given two numbers and their HCF, LCM, they are always equal to the product of HCF and LCM, always equal to product of their numbers, product of the given numbers. So next we can solve the problems. Then you can understand this relationship by solving the exercise problems. Let's see some problems. Okay student, next we can understand the concept to find out the HCF, the given two numbers, and we have to find out HCF. Here the given two number, first number will be 26, the second number will be 91. The given two numbers, we have to find out their HCF and LCM. What are the factors of 26? We know that prime factorization method. From that method, if we find out the factors of 26 are 2 into 13. What are the factors of 91? If you write the 91 factors, you'll get a 7 into 31. So what is the HCF? HCF means it is the highest common factor. The HCF of this two number is 13. Like that, find out the LCM of this two number, because 13 will be a common. 13 is the common factor among these two number. That's why HCF means it is the highest common factor. What is the LCM? LCM is the product of prime factor and common factor and other factor. So if you left 13, if 13 is left means what are the other factor? 2 into 17. So then LCM will be 2 into 17 into 13, that is equal to 182. Whether what you did this problem is right or wrong, we have to verify through verification. What is the relationship? We know that product of HCF and LCM is always equal to product of their given numbers. What is the HCF? 13. What is the LCM? 182. If you multiply HCF and LCM, you will get 2366. Like that, multiply the given two numbers, their product will be also equal to 2366. Then your problem is 100% right. Like that, we can take the second problem. You can understand. Here the given two numbers. What are the two given numbers? 510 and 92. Is it right? Here they given two numbers, 510 and 92. What are the factors of 510? The factors of 510 are 2 into 3 into 5 into 17. Here I didn't done the steps directly. I write the factors. So like that we can find out using prime factorization method in the working step column for your reference. 92. What are the factors of 92? 2 into 2 into 23. So here what are the common factors? Here common factor among the two numbers, 2 will be a common factor among the two given numbers. That's why HCF will be 2. HCF means we know that HCF means it is the common factor among the two given numbers. That's why HCF here 2, and LCM is it is a product of LCM is it is a common factor and other factor. Common factor here 2, remaining other factor. If you multiply, you'll get the LCM 23,460. So through we can do verification. How to do verification whether your problem is right or wrong by using the relationship HCF into LCM is equal to product of the two numbers. So 2 into 23,460, HCF will be 2 and LCM will be 23,460. If you multiply, you'll get the answer 46,920. Like that, if you multiply the two numbers, you will also get the same answers. Likewise, we can solve the problems using this relationship. It will be very useful and it is a very important problem from the point of your examination also. You have to learn and how to transpose. I told you have to keep in your mind A into B is equal to H into L, or they can use P into Q is equal to H into L. Whatever they can Q, P into Q, if they given also you can easily write. P means any number, H into L by Q. If you want to find out Q, H into L by P. Okay, if you want to find out H, P into Q by L. If you want to find out L, P into Q by H. So this is the transposition of the formula. First you have to learn what is the original formula. That means what is the relationship, the main relationship between HCF and LCM. If you understand that concept easily, we can do very easily, you can do the problems. Like that we can solve the problems. It's very easy and very important also from the point of your examination also. You can revise once again, you can observe the steps. I'll revise today in this class what are the points we learned, student. So totally today in this session we discuss two content or two topics. So one will be Euclid's division, lemma and algorithm, and second one, what is the second point? What is the second point we learned? So we learned the second topic, that is nothing but the fundamental theorem of arithmetic. So you have to understand correctly these two concepts. Once again we have to revise the point, whatever the points we discuss in this topic. So we learned first lemma. What is lemma? A lemma is a proof statement used for proving another statement. Algorithm. What is an algorithm? An algorithm is a series of well-defined steps which gives a procedure for solving a problem. And next, what is the concept we learned? Topic 1, what are the concepts we discussed? Euclid's division lemma. What is Euclid's division lemma? Given positive integers a and b, there exist unique integers q and r that satisfies a is equal to bq plus r, where r is always greater than 0, less than b. When a and b are positive integers, then q and r takes the values. And next theorem, fundamental theorem. A prime number p divides a square, then p divides a, where a is a positive integer. Is it right, children? Every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factor occur. It is known as unique factorization. In this we learn factor theory, factor tree also, right? A chain of factors which is represented in the form of tree is called factor tree. They can ask in the exam, express in the form of factor tree. What do you mean by factor tree? Factor tree is nothing but a chain of factors which is represented in the form of tree is called a factor tree. So this is the main concept, main content we have to understand in this chapter, and also we learn the relationship between HCF, LCM and the given number. What is HCF? HCF means highest common factor, product of the smallest power of each common prime factor in the numbers. Right, children? I'll repeat once again. What is HCF? Product of the smallest power of each common prime factors. in the numbers. What do you mean by LCM? Product of the greatest power involved in the number. I'll repeat, sorry. LCM means product of the greatest power of each prime factor. HCF means we have to take highest power of common factor. LCM means we have to take the greatest power. If there is no common prime factor, then the HCF is always equal to